Good day, everyone. Today we are talk about task scheduling. So basically, there are three types of tasks. So the first one is a priority task, is the hard real time. Mostly we use for the data application, system monitoring, that we are not allowed any due that is missed. Second and the third is quite similar, is something about the random or unexpected signal from the system or from the environment, but we classify into soft and hard real time. For the soft one, we call it a priority task, the one for the mouse, keyboard, instruction for the users. If we miss few seconds or few microseconds, they are not going to cause any damage to the system. The third one, same event driven, but we are not allowed to miss any due date. So we need to ensure the system will respond in a very small time frame, for example 2 microseconds for our ABS system. So these are the some temporal parameters that we should familiar with. For example, the release time. So mostly we assume is 0 at the first. The third is the deadline. There are two types of deadline: the deadline and relative deadline. So the relative deadline is something like our period. In most cases, if we know mention. And next is the execution time. In our previous lesson, we call as a CPU time. So it's about the time of a task that require to complete the execution of the task when it executes alone and has all required resources in place. So that means we assume there is no any the memory additional requirement that cause any delay. The context switch is 0. So next is the response time, also known as the completion time. So the completion time is the time that is needed from the task to release to the execution is completed. So that means the CPU time plus the total time of delay, if any. Lastly is the period. Period is the length of the interval between the release times of two consecutive instances of the task. For example, task A, you need to run at time 10 seconds, that time 20 seconds, that time 30 seconds. So the time between two consecutive instances of the task is 10 seconds. So the 10 seconds is the period of this case. So this is a typical activation diagram for a single task. As you can see that when at the release time, so that means a task is ready to run, but maybe not yet run if it's not the highest priority. So for this demo, we consider it's not the first priority. So even though it's in ready state, but the task is waiting. Okay, it's waiting. The CPU is available for it to be done. So so that's why we have a start delay, as you can see here, until the start execution. So this is the start delay, okay, as you require to analyze for your assignment. So in this waiting time is the total time that we delay the task. So once the CPU is available, so this task is executed. So here we put the execution time. Actually the one is the total CPU time of the task. So luckily, if we can complete it without any preemptive, so we complete it. So from the release time to here is the response time, aka as a complete time. Okay, so for example, even though this so for example, our CPU time is only 10 seconds, but since it's not the first priority, so it is in the waiting in the ready state for 10 seconds. So we have a start delay 10 seconds and then plus the CPU time of 10 seconds. So the total response time or the complete time, we need 20 seconds in order to complete this task. Okay, so by the way, this material is from the chapter 4 task scheduling real-time embedded system first edition. Okay, this book you can get from our library for free, as you can see I put the link here. You need to log in the intranet in order to download this book. So now I would like to demo how we can fill in our or how we going to analyze this activation diagram. So this example that we used previously, so I use this pointer as the CPU. So at the time 0, so all the tasks is ready. So we have all the tasks are in the ready state. Since the task A in this case is the highest priority, so we run without any delay for 4 milliseconds. So for the task A, see it's a first priority, so it's a 0 millisecond of the start delay. So after 4 milliseconds that we can run our task B. So in other words, our task B we have a delay of 4 milliseconds. 4 milliseconds. After 2 seconds of complete the task B, that we can run our task C. That means we have in total 6 millisecond delay for our task C. So the CPU time or the execution time are the given, so we just fill in according to the question that already stated how long for each of them. So after filling the CPU time, so how about the period also given, so we just fill in accordingly. That show in the question. So otherwise mention all the deadline that we mentioned in the exam, we refer to the relative deadline. Deadline also given. If not given any deadline, so we assume they are same as the period in such case. Lastly is the completion time. Completion time basically is time delay plus your CPU time. If you don't have any delay, of course you are complete accordingly. If you any delay, you just consider the start delay. So for the task B we have 6 milliseconds, and then for the task B 6 milliseconds, task C is the 10 milliseconds. That means we need 10 milliseconds to complete the task C, as you can see. However, we shall not stop here, we should still keep scanning. So again, for the task A, normally because there's not any preemption, so we can continue. One thing is about the task. The task C, actually task C is not yet complete. Task C is not yet complete, so because here we preempt already at a 10 millisecond preempt already, so it's not complete. So we don't have the completion time yet for our task C, so we still waiting it complete the total 6 millisecond. So still after preempt 4 millisecond, and then CPU is free, so we run another 2 millisecond for our task C. Finally total 6 millisecond has been completed before the deadline. So the time, so that means we delay a while, and then we delay again, but here we are not consider, we consider the start delay is until here only. So total time is how many? Total time is a 4 plus 4 plus 4 plus 2, so it's 14 millisecond plus another 2 millisecond before it complete its CPU. So total is 16 millisecond for this case. For our task C is 16 millisecond. Then we continue scanning. And then task A run, and then task 2 should be run as well at time 20 millisecond, but task A has higher priority, so we preempt task B. Task C. Task B is not yet need to run. So after we run the task C for 6 millisecond without any stop. So here at this point we have new time delay, or the start delay for our task C. The one is a 4 milliseconds, so we need to add here 4 milliseconds for the second round. Only delay 4 milliseconds. The first round delay quite long, delay 6 milliseconds. Here 4 milliseconds, and then complete time become how many? Become 10 milliseconds only. So we have new completion time for our task C. So you need to key in that as well. 10 milliseconds for the second round. So again, task A and task B need to run at time 30 milliseconds. So we have no choice. We preempt task B 4 milliseconds. After that we run 2 milliseconds. So it is similar to the first round, so there's not any new information we need to add to the table, so we can proceed to the next analysis. So this round is similar for the second round. Okay, so basically how we know whether we should start, actually we can based on the hyper period as you learned in last week. Hyper period for this case is how many? Yeah, it's 60 milliseconds as we measure, so we should continue to analyze the rest until we complete one hyper period cycle. So for this round, still same as the second round, no new information. And then I think that's all. So this is our analysis, complete analysis. Okay, so pay attention about the task C. Okay.